Stranger told you just before. I would like to start with thanking Epifysen and SOF for the opportunity to present some of my work here. The title of my presentation is Mobilization and Immobilization Effects on Tendon Repair, a Neuronal Role in Healing. And I would like to start with acknowledging my research colleagues. Achilles tendon rupture is not an uncommon injury in the middle-aged, physically active population. The treatment is either surgical or conservative. And whether we do surgery or not, we usually immobilize the injured ankle for a period of time afterwards, even if we know that immobilization of connective tissue reduces the connective tissue structure's quality. This is followed by often a prolonged period of rehabilitation, and it's not that rare that the injured patient never go back to the same activity level that he had before the injury. So why is that? Well, one of the explanations could be the complex progress or the complex process of connective tissue healing. The process is described as divided in three different phases. The acute phase, the inflammatory phase, followed by the proliferative phase, and finally the remodeling phase, where a lot of different inflammatory cells and stromal cells act and interact in different ways during the different phases. Everything is very strictly regulated. This regulation is done by direct cellular stimulation, the local release of growth factors, cytokines, and different chemokines. However, during the last years, the last decade, the peripheral nervous system has gained an increased recognition when it comes to maintaining peripheral tissue homeostasis. Traditionally, we look upon the peripheral nervous system as leading mainly efferent information to the central nervous system. However, when an injury occurs, there is a release of transmitters in the periphery. And during the acute phase, that is the inflammatory phase and the proliferative phase, these substances are the sensory neuropeptides, where substance P and CGRP, calcitonin gene-related peptide, are the most important ones. So, what do we know about these substances? Well, substance P, for instance, has been shown to stimulate all steps, more or less all steps, in the healing process, while CGRP stimulates the earlier phases, that is the inflammatory phase and the proliferative phase of healing, where it also has some inhibitory modulatory effects. What do we know about the tendon, the situation in the tendon? Well, an uninjured tendon is virtually devoid. There is no nerve fibers within the proper tendon tissue. However, after rupture, there is a significant ingrowth of nerves expressing substance P and CGRP inside the healing area. This expression is done in close vicinity to its effector cells. This picture shows sensory nerves expressing substance P, that are the red lines, and the green dots are actually macrophages in close vicinity. And these are cells that are known to express the receptor for substance P, the NK1 receptor. Given that the peripheral nervous system is important for regulation and stimulation of tendon healing, it could be that the negative effects of immobilization could be mediated by changes in the peripheral nervous system. So in order to investigate this, we used 260 rats, where most of them underwent a blunt tendon rupture. During the healing process, these animals were allowed 3 different levels of physical activity. One group were immobilized using a plaster of Paris. One group were allowed free cage activity, and one group were allowed to run freely in running wheels. The animals were followed for up to 16 weeks when they were sacrificed, and the Achilles tendon were harvested. Analysis of the tissues were done with histological analysis, immunohistochemistry, and quantitative analysis with PCR. Looking at the tendon diameter after 4 weeks of healing, it turned out that the more physically active the animal had been during the healing process, the larger were the diameter of the healing. These results were confirmed when looking at the tissue maturation, which we see to the right, where the running group had much more organized collagen in the healing area, and the immobilized group had less organized collagen and much more inflammatory cells. When we followed the animals for 16 weeks, we got this long curve showing a gradual increase in the diameter of organized collagen. When we blended the results from these two studies, we saw that the difference in tendon diameter in the healing area corresponded to a healing period of 11 weeks. So we could, we could speed up the healing with about 11 weeks in 4 weeks by having the animals move frequently and as much as they wanted to. So why is that? A plausible explanation was found when we looked at the receptor expression for these substances. NK1 is the receptor for substance P, while CRLR RAMP1 receptor complex is the receptor for CGRP. If you look at the diagrams after about 1 week of healing, there are no significant differences. But after about 2 weeks of healing, there are almost no expression in the mobilized group, while in the mobilized group, there are very large increase. So, short, if you immobilize an healing tendon, the tendon will be virtually insensitive to stimulation of the peripheral nervous system. This pattern was also seen looking at several different growth factors and pro-inflammatory molecules, some of which are shown here. Interestingly, substance P has been shown to stimulate the expression of several of these factors. Further on, looking at the actual synthesis of the structural proteins, this was what we found. After 1 week of healing, there are again no differences between the immobilized and the mobilized animals. The collagen 3 expression and the biglycan expression is significantly increased. But after 2 weeks of immobilization, again, it seems like the healing process in the immobilized animals is almost shut off. No healing occurs. The synthesis has actually returned to control group levels, while in the mobilized group, the expression has increased in some instances over 1,000%. So, shortly to conclude, early mobilization after tendon rupture enhances healing. A shorter period of immobilization, that is in this instance during the inflammatory phase, doesn't seem to negatively influence the healing process. However, a prolonged immobilization seems to slow down and in some instances actually shut down the healing process itself. It seems that a fully functioning peripheral nervous system is a prerequisite for a normal healing process. The data from these studies seem to support a more aggressive and early rehabilitation of injured connective tissue. Thank you.